Our lesson today, we're going to turn to page 397 just to get started. Our lesson actually starts on page 398, but I just wanted to draw your attention one more time to the formula here for figuring out combinations that we talked about yesterday. Okay, so it's very much like the permutation formula where we had to figure out permutations, how many arrangements of n number of objects taken this many at a time, r at a time, is n factorial over, and then n minus r factorial on the bottom. Okay, the only difference between that and the combination formula is then we're multiplying by the number of items we're taking at a time, factorial one more time. Remember that you would use this formula when you are arranging or when order matters. And you would use combinations when order does not matter. Okay, and really get that clear in your head. Combinations, you're just combining things randomly. Permutations, you are arranging them in a specific order because order matters. Okay, so we're going to flip over to the next page and we're going to do the last example where we left off yesterday. And in this case, we're dealing with a standard deck of 52 cards. It's coming back again, so we really have to know our decks of cards and the characteristics of each deck. Luckily, they have given us these characteristics again because it's been some time since we've talked about them. Cards have 4 suits. You've got your spades, 13 cards that are spades, 13 cards that are clubs, 13 cards that are diamonds, 13 cards that are hearts, to make up 52 cards altogether in the deck. Okay. 2 suits are black, so you have 26 black cards, 13 that are spades, 13 that are clubs. And you have 2 suits that are red. Same thing again. 13 that are diamonds, 13 that are hearts. And when it talks about face cards, it's talking about jacks, queens, and kings. The cards that actually have a face, okay? Not the joker, jacks, queens, and kings. Okay, so poker is a card game that is played from a deck of 52 cards. How many different 5-card poker hands are possible? Okay, well, when you're just randomly dealing cards, order doesn't matter. You're not arranging them in any particular order, you are just dealing them, okay? So that would be a combination question. How many cards are you choosing from altogether? 52. And how many cards are you giving each player? How many cards are you choosing? 5. So out of 52 cards, you are randomly choosing 5 when you're dealing. Okay, if you plug that into your calculator, 52C5 is 2,598,960 different possible combinations of cards that you could deal. Okay, B says, in how many of the hands in A will there be all diamonds? Okay, well, all diamonds, how many cards would we have that would be diamonds? Okay, diamonds. Each suit has 13 cards. So we've got 13 cards that are diamonds, and we're choosing all 5 of them to be diamonds. So out of 13 diamonds, we're choosing randomly 5 of them. 13C5, 1,287. Okay, now this time we're dealing 5 cards again. So we're dealing 4 black and 1 red. Okay, so we would set the question up this way. How many black cards would there be that we could choose 4 from? We've got blacks, 2 different suits that are black. Okay, and each suit has 13 cards. So that means out of 26 black cards, we are randomly choosing 4 blacks. And, so we're multiplying, that means times. We're also choosing out of the reds, how many reds would there be? 26. We're randomly choosing 1, right? So this is choosing our blacks. This is choosing our reds. Okay, we're choosing 4 blacks, 1 red. Okay, out of 26 blacks and 26 reds altogether. And that would give us 388,700 different combinations of hands we could hand out that would have 4 black cards and 1 red card. Okay. This time we're dealing out 5-card hand that has 3 kings and 2 queens. Okay, so let's see, how many kings do we have to choose from? Well, there's a king in each of the suits. 1 king that would be spades, a king of clubs, a king of diamonds, a king of hearts. So there are 4 kings we can choose from. We're choosing 3 of them. And we are choosing 2 queens. Well, how many queens are there that we could choose from? Right, there's a queen in each of the 4 suits as well. So out of 4 queens, we are choosing 2. Okay, and that's 24. If you calculate that in your calculator, plug it in just like it is with the brackets, and using your combinations button, it will do the multiplying by for you, and it'll give you an answer of 24. Okay, in how many of these hands, these 5-card hands, would you have 3 kings? Well, you'd have 3 kings, and you'd also have 2 cards that are not kings, right? Okay, because you have to have 5 cards in your hand altogether. So 3 would be kings, 2 would be non-kings. Okay, so let's figure out 3 kings. So I'm choosing out of 4, I'm choosing 3 kings. And I'm also choosing out of the remaining cards, I'm choosing 2. Now, how many remaining cards are there? If I've already chosen my kings, so I've taken these 4 out of the deck, then how many cards are left in the deck that I'm choosing from? Right, 48. Out of 48 cards left that are not kings, I'm choosing 2. Okay, because I have to make sure with this second situation here that I'm choosing from the cards that are not kings. So those 4 kings are taken out of the deck. I have 48 non-king cards left that I'm choosing 2 out of. Okay, when you calculate this on your calculator, plug it in, you will get 4,512. Okay, my next hand that I'm handing out needs to have 4 aces, so that would mean and 1 non-ace. Okay, so to calculate that, out of, okay, how many aces would there be I could choose from in a deck? Right, out of 4 aces, I'm choosing 4. Oh, 4C4. And then how many non-aces would there be in a deck? Well, if there's 4 aces in a deck of 52, then there's 48 non-aces, right? And I'm choosing 1 of them. And if you calculate this, plug it into your calculator, it'll give you an answer of 48. Last question. 5 cards, all of the same suit. This is called a flush in poker. So this means I have either 5 clubs or 5 diamonds or 5 hearts or 5 spades. Okay, so what that means is, I'm using or this time because I've got either this or this or this. I don't have them all. When I see or, remember that means I am adding. Okay? So out of, let's see, how many clubs would there be in a complete deck? Right, there are 13 clubs, and I'm choosing 5 of them. Or for diamonds, how many diamonds would there be in a deck? 13, right? And I'm choosing 5 of them. Or, how many hearts would there be? 13, and I'm choosing 5 of them. Or spades, 13, and I'm choosing 5 of them. Okay. I could have written this, and maybe for plugging it into your calculator, it's going to be easier to say this is 4 times 13C5, right? That's the same thing. Okay, so for plugging it into your calculator, that will be an easier way. But we really are adding them, and we have 4 of them. They're identical, so it's 4 of those to calculate it. That'll give you an answer of 5,148. Okay, so now between the lesson that we did yesterday and this that we've just finished up of that lesson today, you will be able to go ahead and do the questions at the end to practice combination questions. Okay, so do complete those questions. But we are going to go on and do part 2 of combinations as well today. And so you'll have time at the end of class to come back and work on these questions, numbers 1 to 12. Okay? So if you could flip over in your book 3 pages to part 2 of this lesson, we'll continue here for now and come back and do the assignment later. Okay? So this is combinations again, when order does not matter. But this is combination problems where you see the words at least or at most. Okay? And these are a special type of question. Okay? So class example number 1 says, the student council decides to form a subcommittee of 5 council members to look at how funds raised should be spent on the students of the school. There are a total of 11 student council members, 5 males and 6 females. How many different ways can the subcommittee consist of? Exactly 3 females. Okay, so what this means is we're going to have 3 females. So how many males will we have? Right, okay, because it tells us we're making a subcommittee of 5 members. Okay, so we have to have 5 accounted for altogether. If 3 have to be females, the other 2 will be males. Okay, now we're just choosing randomly. It's not telling us that these committee members are going to be president, vice president, secretary, treasurer. It's just telling us it's a subcommittee of council members. In other words, they're members at large. Okay, so order is not important. We can choose randomly. Okay, so out for females, we're choosing from a pool of 6. So 6, choose 3. And we also are choosing our males. So and means times. So out of 5 males, we're choosing 2. If you plug this into your calculator, you'll get an answer of 200. Now, this question though says we have to have at least 3 females. Okay, what that really means is I can have 3 females, or 4 females, or 5 females, right? It's different than this question where I had to have exactly 3 females, okay? This one I have to have at least 3, so I can have 3, or 4, or 5. So there's really 3 separate cases that I have to figure out here. And when I have this word or, this means I'm going to add, right, the separate cases together. Okay, so the one where I have 3 females, okay, actually maybe I'll just do it, write it down here. So 3 females would be out of a pool of 6. I'm choosing 3, okay, but I also have to choose my males because my council still has to have 5 council members, okay? So I have 3 of them are females, then the other 2 are going to be males, and I'm choosing from 5 males, choosing 2 of them, okay? This is case number 1, 3 females. So that means 2 males, right? And then it's or case number 2, 4 females. So out of the 6 females, I'm choosing 4. And then that means how many males am I choosing? Out of the group of 5 males, I'm choosing one of them, right? Okay, so this is where I have 4 females, 1 male. Okay. Or my third situation here, 5 females. So out of the 6, I'm choosing 5 females, and that means out of the 5, I'm choosing no males. So this is 5 females, 0 males. When you multiply this, you can actually figure out, if you prefer, you can figure out just what this first part is here, which is 6C3 is 20, and 5C2 is 10. And then you can add that to and figure this one out, which 6C4 gives you 15, and 5C1 gives you 6. And then you can figure out this third case here, which 6C5 gives you 200, and 5C0, okay, gives you 1. Don't be confused by that. There is one way to choose no members out of a group of 5, and that is 1. So 5C0 does not equal 0. It's not like 200 times 0. It's 200 times 1. Okay, anything, there's one way to choose no members, right? Okay, and when you, or if you don't want to break it up and figure each one out separately and then add them together, you actually can plug this whole great big long thing into your calculator all at once. It's just, it gets a little arduous when you plug that many things in all at once, but your calculator can do it and can handle it. Just be very, very, very careful. Double check. Make sure that you've entered your numbers in correctly once you've got this great big long string of 6C3 times 5C2, and make sure you've got all your brackets in the right spot. But it will handle it and it'll do it for you. Okay, but if you did it this way and you split it up like this, it would give you a grand total answer of, this is 200, this is 75, and this is 200. Oops, I'm sorry. Not 200. Sorry, that was 6 times 1. I was looking at the wrong line. Okay. And so that will be plus 6, as for a grand total of 281. Oh, and I really was looking at the wrong line, because this, I'm sorry guys, this was supposed to be 15 times 5 plus 6 times 1. Sorry. 75, and this is a 6. Okay, sorry. Be very careful with your numbers. Don't look at the wrong line. I was looking at the wrong line. Okay. This last question says,
Paige and Haley to the office, please. Paige and Haley to the office.
That in our subcommittee we have to have at least 1 female. So that means we have different cases again that we need to consider. We have 1 female, or 2 females, or 3 females, or 4 females, or 5 females. So really, we have 5 different scenarios we need to consider here. Okay, so if I'm choosing 1 female, okay, so that means out of the 6, I'm choosing 1. So then how many males would I be choosing? Right, the other 4 would be males. Okay, so this is the situation where I have 1 female, 4 males. Okay, or, so that's my plus. I would have choose out of the 6, choosing 2 females And out of the 5, then I'd be choosing 3 males. Okay. This is 2 females, 3 males. Or I might, out of the 6, this is 1 female, 2 females, 3 females. And in that case, then I would have, out of the 5 males, I'm choosing 2. This is 3 females, 2 males. Still making a committee of 5. Or I might have 4 females and 1 male. Or out of the 6 females, I'm going to choose all female, or all 5 of them females, and that means out of the guys, I'm choosing no males. So this is 5 females, no males. Okay, so this looks like a really long thing to plug into my calculator, and really it is, except we've already figured this whole part of the equation from at least 3 females. This part here, where we had 3 or 4 or 5 females, we did that right here in this question, didn't we? 3 females, 4 females, or 5 females. So we've got our answer here that we can use. So we know that this part of the equation is 281, this whole part here. Okay, so we don't have to waste our time calculating all that again. Okay, but this first part here, 1 female, 4 males, well, that's 6 times 5, plus this part here, 2 females, 3 males, that's 15 times 10, and then plus this 281. Okay, so when you do this, you calculate it on your calculator, you should get an answer of 461 as your final answer. Okay, here's another question again with a standard deck of 52 cards. And again, we're building a 5-card hand. And in this case, this hand has to contain at least 1 red card. Okay, so again, I've got situations here. I have 1 red, and I'm going to show the separate cases vertically this time instead of a great big long stretched out horizontal line, just because I run out of space when I come to B, then it becomes a problem. But it's the exact same thing. I'm going to figure out each distinct case and then I'll just add them together, because it's 1 red or 2 reds or 3 reds or 4 reds, or I might have all 5 reds. Okay, so in this case, if I had 1 red, okay, how many am I choosing from that would be red cards in a deck? Right, a deck is 52 cards, and half of it is black, half of it is red. So out of 26, I'm choosing 1 red. But I also have to choose the rest of my cards, which is the blacks. So out of the 26 blacks that are left, I'm choosing the other 4 black, right? Okay. And then 2 reds. So out of the 26, I'm choosing 2 reds. And out of the 26 blacks, I'm choosing 3 then. And 3 reds would be out of the 26. I'm choosing 3 reds. Out of the 26 blacks, I'm choosing 2 reds then to make my 5 cards in my deck, in my hand. Then for 4 reds, I'm choosing, out of the 26, I'm choosing 4 reds, and I'm choosing, out of the 26 blacks, then I'm choosing 1. And for 5 reds, out of the 26 reds, I'm choosing all 5 reds, which means, technically, I'm not choosing any blacks. Okay, so if you calculate each one of those separately and give yourself a total, pause the movie at this point, or the video at this point, and then restart it again and check your answers with mine. Okay, so if you figured out each separate case, these are the numbers that you should have got. And when you added each of those together, because it's either this, 1 red, or 2 reds, or 3 reds, or 4 reds, or 5 reds. So you're adding them together, you would have got a grand total of 2,533,180 different hands can be formed that would contain at least 1 red card. Okay, now I am going to need to erase this, so if you are busy copying this down, you should pause the video and then restart it again once you're ready. Okay, the next question says, this time, how many different 5-card hands can be formed that would have at most 2 kings? So that means you might have 0 kings, 1 king, or 2 kings, okay? Right? At most 2 kings. So we've got 3 separate situations here. So let's figure out, I think we can do 3 separate situations horizontally. If I have 0 kings, how many kings am I choosing from in a deck? How many, in a full complete deck of 52, how many kings would there be? 4, right, there's 1 king in each of the suits. So out of 4 kings, I'm choosing none. And I'm also choosing the rest of my cards to make this 5-card hand. So this means no kings, so then I would have 5 cards that I have to choose out of how many cards would be left if I've taken all of the kings out of my deck? Right, I have 48 cards left, so out of the remaining 48 cards, I'm choosing the other 5. Or, second situation would be 1 king. So out of 4, I'm choosing 1. And out of the remaining 48 cards, I'm choosing the other 4 cards in my 5-card hand. Or, I might choose 2 kings. So out of the 4 kings in the deck, I'm choosing 2. And out of the 48 cards remaining, I'm choosing the other 3 cards for my 5-card hand. Okay, when you figure this out, you can plug this all into your calculator, or you can figure out each case separately and then add them together. You would get a grand total of 2,594,400 different ways that you can deal a 5-card hand that would have at most 2 kings. Okay, we're going to skip the last question on this page just for time's sake, because I do want to go over one other thing with you before our time is up. If you flip over 2 pages to page 403, we're going to talk about polygons and diagonals. Okay, so we've got 2 circles here that have 5 points marked on the circumference of each circle. How many triangles can you form using these 5 points? And we need to write our answer in combination notation. Okay, so if I build a triangle, it's going to take how many points on this circle? 3, right. Okay, so if this is a combination, what that means is it's random. It doesn't matter which dots I use. So out of the 5 dots, the 5 points that are marked on this circle, I'm going to choose any 3, right? If you plug this into your calculator, 5 choose any 3, you get 10 different triangles that can be formed. Okay, B says how many lines can be drawn connecting 2 points on a circle? And we have to write this in combination notation. Okay, so again, out of the 5 points, I'm randomly choosing any 2. So 5C2 is 10. Okay, then C says, sketch a regular pentagon. Okay, pentagon, 5-sided shape. Right, so 5 equal sides. Do your best to try and get 5 equal sides. It won't be perfect, but close as you can get it is fine, okay? It says how many lines can be drawn connecting 2 points on the pentagon, including the sides of the pentagon, okay? So what that means is we're going to be connecting 2 points on the pentagon. So we could connect like here, or we can connect here, or here, or here, or actually these ones connect 2 points as well, right? Okay, so how many lines can be drawn totally connecting all of any 2 points, including the sides of the pentagon? Well, this is again, out of how many points did we have on this pentagon? Out of 5 points, we were connecting any 2 of them, and 5C2, we figured that out up here. 5C2 is 10. Now, how many of these lines actually are classified as diagonals? Now, a diagonal in a pentagon or in a polygon is any points that are across from each other inside a shape. Okay, so this one would classify as a diagonal, this is a diagonal, this is a diagonal, this is a diagonal, oh, and that would be a diagonal. I missed that one before. Okay, so that's what it's asking. This time it's not asking about the outside walls, it's wanting the diagonals which are inside the shape. Okay, well, how many were we able to draw? 1, 2, 3, 4, 5 of them. So if we were to write this in terms of combinations, okay, our combinations here, this told us how many lines we were able to draw that would connect 2 points. 5C2, so 5 points, and we're connecting or choosing 2 of them. If we then subtract the number of sides that are like the outside sides of the shape, 1, 2, 3, 4, 5, then we would get our answer, because we know that 5C2, we figured that out up here and up here, 5C2 is actually 10, and then we're subtracting 5 because that's the outside of the shape that we don't count, and that would give us an answer of 5. There's 5 diagonals inside the shape. Okay, let's see if that actually holds true in any polygon. Okay, so D asks us how many diagonals are there in a regular octagon? Well, how many sides are there in an octagon? Right, 8. Okay, so out of 8, we'd have 8 sides, so we'd also have 8 corners, okay, vertices in that shape. And we're drawing diagonals, so that's a straight line between any 2 points. So we're choosing any 2 points, so 8C2. And then if they were diagonal, that would give us the total number of lines that we could draw, including the outside edges. So then we'd have to subtract the number of outside edges, because diagonals are inside the shape, right? It doesn't include those outside edges. So we'd have to subtract 8. Okay, so let's see if we can generalize then, if we just use n, the variable n, instead of like 8-sided polygon or 5-sided polygon. Okay, so this is the general rule. The number of sides of your polygon, and then a diagonal chooses 2 of those vertices to draw a diagonal line. Okay, and then we have to subtract the number of sides of the polygon. Okay, so this is your general rule here for finding the number of diagonals in a regular polygon that has n number of sides. Okay, now another way that you might see this written, sometimes you see n over 2, and that means the same thing as nc2. Okay, you'll see that notation occasionally, and then you subtract the number of sides. All right, so here's a really big polygon. This one has 65 diagonals, and we have to algebraically determine how many sides it has. So we're going to use this formula here. We're going to plug in what we know into this to see if we can solve for n and figure out how many sides it has. Okay, so our formula is NC2 minus n is going to equal the number of diagonals, right? This is the number, tell how many diagonals there are in that shape. In this case, they told us this polygon has 65 diagonals. Okay, so NC2, we have a formula that we can use to help us figure out what NC2 really means. If you remember, looking back, couple pages at what our NC2 formula really means, this formula right here. Okay, we're going to use this formula, which explains what this notation really means. So it's n factorial over this minus this, and then times by this one more time. Okay, so that's what we're going to use here. So down here, NC2 really means n factorial over n minus 2 factorial times by 2 factorial again, right? And then the rest of this minus n equals 65. Okay, now I know how to simplify this using factorials. Remember before we learned that we take, when we have a ratio here of factorials, you look for which one is the greatest value, and you start expanding it until it matches a term in your denominator, and at that point you stop, because then they'll cancel each other out. So that's what we're going to do. I'm running out of space here a little bit, so I think we'll continue this up here. So which one is greater, n factorial or n minus 2 factorial? Right, n factorial is greater than 2 less than n, which is what n minus 2 means, right? So we're going to start expanding the top. So we've got n. 1 less than that would be n minus 1. 1 less than that would be n minus 2. And I can stop there and put the factorial sign to show that it continues on and on and on, because now it matches my n minus 2 on the bottom. I still have that 2 factorial on the bottom. And I actually still have the rest of my equation. I don't want to drop it off because then I'll forget about it. So I'm going to put the rest of the equation in there. Now this n minus 2 factorial will cancel this n minus 2 factorial. So really what I have left at this point is n times n minus 1 all over 2 factorial. And that, oops, not equals, minus n equals 65. Okay, now ultimately I need to solve for n. But right now I'm running into a bit of a problem because I have a 2 factorial in my denominator. So to get rid of that 2 factorial, first of all, what is the value of 2 factorial? Right, that's just 2 times 1, which is 2. Okay, so this is really a 2 in the denominator. I need to multiply both sides of my equation by 2 so that I can get rid of that 2 in the denominator. Okay, when I do that, multiply n times n minus 1 all by 2, then that's going to cancel out the 2 in the denominator here. So really I just have n times n minus 1. But then I also have to multiply this negative n by 2, so it's negative 2n. And I have to multiply the left side, or right side, 65 by 2, so that's 130. Okay, so you see how we did that? If I multiply 2 times this whole thing, and I'm multiplying this whole thing by 2, right? When I do this, 2, and this has a value of 2 right here, okay? That 2 is going to cancel that 2 out, right? So it's really going to be 2n times n minus 1 all over 2, but the 2 and the 2 on the top will cancel each other out, right? Okay, so Okay, so what I've really done is multiplied this by 2. So I've got 2n times n minus 1. And then the 2 and the 2 on the top are going to cancel each other out, so I'll just have n times n minus 1, this part. But then this 2 I have to times by this negative n, so that's where I got this from. Okay, everybody's with me? Okay. Okay, so now I have n times n minus 1 minus 2n equals 130. So I'm going to have to multiply this out. So this is going to be n squared minus n minus 2n equals 130. I have to collect my like terms here, so I've got n squared minus 3n. And then ultimately I need, because this is quadratic, I'm going to end up having to factor. So I'm going to skip a step and just subtract 130 from both sides. So bring that 130 over to the left side so that my whole equation will equal 0, because then I can factor it. So I'm looking for two numbers that will multiply to give me negative 130 and add together to give me negative 3. Negative 10, nope, negative 13 and positive 10. Right, that'll give me negative 130. It will also add together to give me negative 3. Okay, so if I solve, n minus 13, make it equal to 0, and n plus 10, make it equal to 0. So n equals 13, or n equals negative 10. Now the problem is, n can't equal negative 10, because if it did, then this equation here would say negative 10 factorial. And remember, you can't take the factorial of a negative number. So you're going to reject this answer, and n equals 13 will be your answer. So this is telling you that this polygon has 13 sides. Okay, so there is a homework assignment that goes with this lesson as well. This was questions 1 to 15. And the other lesson was questions 1 to 12. So you have the rest of this period now to work on those assignments. And then the rest we'll have to do for homework.